Alright guys, hi. I welcome you all in this session where we will learn about few Python modules or libraries which are used in data science and machine learning, isn't it? Because as in data science, we know we have to play with larger scale data. We have to find out insights of larger scale data. Okay, we have to visualize the data, right? So that's a kind of a multiple step process that we have to follow, okay, to access the information out of a data, isn't it? So to do all those things, we take help of few modules or libraries, okay, which are open source in Python. Okay, because if we don't use it, okay, our job may be very complicated. To make our job easier, we use these modules or libraries, right? I just listed few of them, and we learn each of them one by one, okay, in upcoming sessions. Okay, so first it's like NumPy. You know why NumPy will be used? The name NumPy, many people call it a numerical Python, right? To do some numerical operations on what? On large multi-dimensional array or matrices. If you have a large data set and you want to do some numerical operations on that, some computation on that, so NumPy can be a useful tool. Okay. Pandas will be used for what? Pandas will be used for data manipulation and analysis. Okay. Like suppose you have a 1000 100,000 samples, okay, and I want to manipulate it. Like suppose I have to change the type of data, or I have to suppose the sales value is given, quantity is given, and I want to calculate the price of each item, right? So these kind of data manipulation, or kind of changing some structures in the data, applying some functions in the data, we use pandas. Matplotlib will be used for data visualization. This guy will also be used for data visualization. Just both, they are two different tools which are highly used for data visualization, having slight difference. But yeah, if you have a knowledge of any one of these, it will be good. Okay, then after pre-process, these four tools mostly used for what? For data pre-processing, which is major a step for a machine learning project. In machine learning project, these things will be used for, this will take your 70% of your effort. 70% of your effort on what? On kind of on preparing a data for machine learning use cases. Okay, like data is given, data will be given in a raw format to you. Data will not be given in a pre-processed format to you. It will be a raw data. Excuse me. And with the raw data, we have to find out the insights that can be used by the machine to learn something. Okay, and that is called machine learning. No worry, we will deep dive into the machine learning in upcoming sessions, right? Here I'm just giving you a brief kind of understanding that if I want that my machine should learn something from the existing data, like we learn from our lives. Okay, we learn from our life experiences from schools, college. Okay, so what is important for us? If you want to learn good, you will read good books, right? If you will read bad books, right, kind of if the incorrect information you will read, obviously you will not learn a good concepts. Okay, so good schools, good college, good books, these things we search for to learn better, right? So it's like, if we have to make a machine learn, it is very important that the data that we are providing should be good. Okay, it's not like that any information, any random or any kind of wrong information we are providing to the machine will learn, but it will not learn good. So that's why this thing will be used after the data pre-processing. Once the data is pre-processed, thereafter what we use scikit-learn. Why we use scikit-learn? We use scikit-learn for the machine learning purpose. So this will take your maximum 30% of the effort. Okay. And the next step of machine learning is what? Deep learning. Okay. Where we will mostly use what? The unstructured data such as images, videos, text, audio. So we'll go to this stage as well. Okay. And in coming sessions, we'll also go for generative AI. But first we have to start from the right from the scratch. That means it's like we have to understand NumPy, because first we learn what ABCD, then we know how to create words, okay, from that single characters, then from the words we create sentences. So that's why we have to learn this thing first, okay, so that we can make use of it wherever it required more efficiently, right? What we are going to learn first? NumPy. Okay, so what we should do, what should be our kind of a plan, or what should be your plan of attack, right? So to learn NumPy, so we'll learn this thing in 10 steps, okay, or you can say 10 different concepts that we're going to learn. First, we'll start with the basic concept, obviously, where we try to understand what is NumPy. Okay, thereafter we'll learn how to create an array, on how we'll do the manipulation on it, indexing, slicing, array operations, broadcasting, fancy indexing, universal functions, linear algebra, random number generation, and data analysis task at the end we do, right? In case if something that I don't, suppose I had not covered, okay, and you want me to explain that part, please do let me know. You can comment and you can let me know that, okay, this is a topic that I had not covered. Okay, I'll try to, kind of cover that thing as well, right? So let's start with the NumPy. Okay, so what NumPy does, see over here, when we talk about, just a minute. When we talk about the NumPy, right, the name is what, uh, just a minute, NumPy. Okay, so people call it what, numerical Python. Okay, so for numerical operations, why we need NumPy? This is a very first question. Okay, because without NumPy also you can do a lot of numerical operations in Python. Okay, basically NumPy is required when we have a data which is in a matrix form like this 1 2 7 2 5 3 1. Let's say 3 9 2. Okay, so this is what, this is a multi-dimensional data. This is a two-dimensional data, right? So whenever we have a two-dimensional data and we want to do some operations on that, then we use NumPy. Okay. If we are just working with a scalar value, like I'll show you in Python. Okay. I hope you are aware with the Google Colab, right? So if you are not, then I'll create a separate video. It is very simple. You can just go to collab.research.google.com. Okay, I'll show you. This is your online platform where we can write the Python script. All right. Here I can go. All right. And thereafter, it will ask me to get login using my Gmail ID, right? So once I have my Gmail ID, I can easily get logged in. I'll show you. Here you can log in from here, sign in. And then we have a file option and the new notebook. Once you click on new notebook, you will get this thing. The benefit is the file will always be saved at your Google Drive. Okay, sharing will also be easy. Okay, so first start with the NumPy library, right? So NumPy, okay, before going for the NumPy, let's say if I'm having a scalar value a is equals to 7, okay, and I will just write over here a multiplied by 2, it will perform the mathematical operations quite easily. Okay, there is no such problem in doing the mathematical operations over here. Okay, but in case suppose I have a collection of values, okay, and then I want to do a new operation over here, right? So in that case, you can see the result. Okay, let's see the result over here. Okay, so you can see the same values gets duplicated, right? It means what? It means we have to create a loop that can process each value one by one. So again, that will be a kind of, if we have 5, 10, 20 values, then somewhat it is possible. But suppose if you are working on a multi-dimensional data value means suppose you are working with kind of a things, you are working with these kind of data value. Okay, let's see, as I created 192753621. So in that case, doing the numerical operations will be little difficult. Why it will be difficult? Because in that case, you have to take two coordinates, x and y coordinates, right? That means you have to run the loop in two directions. First this direction and second this direction, right? So again, if you're running a loop in two different directions, you have to write a more complicated logic. So chances of error will be higher, right? So that's why NumPy can be a better option for us to work with multidimensional data, isn't it? So let's take some example. Let's try to create some NumPy array and then we will work on that, right? We'll try to do some processings on that, all right? So let's try to understand the NumPy things, right? So now do the same thing using what, the NumPy module, right? So if we are going to use any module in Python, we have to write import and the name of the module. So here we wrote import NumPy as np, right? And thereafter we'll create some array, right? So how can we create an array? Let's see, array one is equals to what, np.array, right? And here we can just feed same value that we feed 4 3 2 1 9. Okay, and thereafter we do what, we'll just print this guy. So let's see, so this is my array one. Okay, now if I want to do any kind of operation, right, so arr1 multiplied by 3. So it just get operated and we get a output, right? So you can see when it was a simple list, the operation was not that much. When we try to do operation, we were not getting the desired result. We want element wise multiplication, but we were not getting that. Here we are getting it. That means the numerical operations will become slightly easier if we are using numpy array, okay, with a large collection of data. Okay, so here we created an array. This array is basically a one-dimensional array. How can we check an array's dimension? We can check an array dimension like this, like array one dot number of dimensions. How can we check the shape of it? We can check the shape of it like this, array one dot shape. Okay, can we? Then the third thing that we check in an array, which is called size. Okay, dot size. Fair enough. Next thing, when we talk about array, right, it's like one dimensional. I had get it. Can we do two dimension? Yes, we can go for two dimensional as well. Let's say numpy dot array, right, and thereafter we do what? We will create over here a two dimensional array. How do we create two dimensional? Let me tell you. I'll 3 4 5, okay, and thereafter 4 3 2, okay, and thereafter I will enclose it within a bracket, right, and then we can pass this thing to a array. All right. Okay. And then this is what? Array 2, right? And thereafter we have what? Let's print it. Okay. And then here I'll print the shape of this guy. Print array 2 dot ending. That is number of dimensions. Okay. And thereafter print array 2 dot shape. What is it? The shape. Okay, that is 2 cross 3, 2 rows, 3 columns. So this is like a matrix, right? Thereafter print array 2 dot size. So this is like size, like what is the size of array? So it is having what? 2 plus 3 total 6 values, right? So what we had seen over here, we had seen how can we define an array? What is the difference between a list and an array, right? The operations will be more easier. And second, more important definition, one important difference, list is basically heterogeneous. Heterogeneous means what? List can have you know the values of multiple types. Sometimes people ask these questions in interview, okay, that what do you think, list is a heterogeneous or homogeneous, right? So please do take your list is a heterogeneous but array is homogeneous. Okay, array will always be numpy array will be homogeneous. Let's see, array 3 is equals to np dot array, right, and I'll do what? I'll just pass the same value over here, the same list over here. Okay, and let's see. So this is a homogeneous. That means here the type of values will always remain, all will be a string. So list is heterogeneous, array is homogeneous. Most of the time we'll use array in its numerical form. Array can be one dimensional, array can be two dimensional, or array can be three dimensional as well. Okay, we can check the 4 dimension, 5 dimensions are also there, but mostly we are going to use up to 3 dimension. Here mathematical operations are very easily can be done. We can check the shape and size of an array. Okay, we had seen one dimensional array, we had seen two dimensional array. Let's see, if I want a three-dimensional array, what can we do? Very simple. Array 4 is equals to what? Let's see, I'll define the same thing over here. Okay, and then I'll define same thing one more time. Let's say I'll make it 13, 14, 15. Okay, 14, 13, 12. And thereafter I'll enclose this thing within a bracket, and then I'll give it a name, np.array. All right, fair enough. Okay. And then print ARR4. So what it will have? It will have two floors, okay, two floors, two rows and three columns. That's why if I check the shape of it, array 4 dot ending, what is the dimension over here? We will have 3 dimension. What is the shape over here? Array 4 dot shape. It would be 2 cross 2 cross 3, right? 2 is what? This 2 is basically, if I have to explain this thing, this 2 is representing the floor. Okay, this is my floor, floor 1, floor 2. This 2 is representing the rows. Okay, in each floor we have 2 rows, right? And this 3 is representing the columns. We have 3 columns. All right. So this is what we have. All right. Now we have what? If I will check the size of it, so it will give me the total number of array 4 dot size. Okay, what is the total number of values in this array? I hope you understood this thing, right? In the next session or in the next video, what we are going to do, we had seen the basic concepts, we had seen the array creation. In the next session, we'll discuss the array manipulation, indexing, and slicing. Okay, so this thing we are going to discuss. Array creation already we had seen. Let's discuss the array manipulation in the next session. We'll keep the video shorter so that you can go through these things easily. Thank you, everyone.